Now since we have Ansible installed, we can go to cd/etc Ansible, and there should be host file. Edit it, go to bottom and create two group. One is, let's say, master. It should have only one HDP m2.cluster.com, one machine only, and one more group, slave, hdps1.cluster.com, hdps2.cluster.com, right? So these are two groups, master and slave. Save it. Now we can do Ansible, try to ping each one of them. So let's try to ping the master first. Let's see if it goes well. Yes. Now try to do same thing on slave. Ansible requires passwordless SSH for root for whichever user you made it. Okay, so now successfully it does ping on it. So Ansible can now see all these hosts. Okay, so you can again do for all. When you say all is a group in which all the nodes will come. Like I said, S1, S2 and M2. It pinged all of them. So Ansible is set up. Now we can copy all the other information using Ansible to the respective nodes. And this is that thing. So create one Ansible playbook and put it there. VIA will say setup.yml. Host slave, yes, root user. So we will first copy this etc host to all the etc hosts, say Linux, syscontrol file, IP tables to be stopped, no disabled, and NTVD just started. So just do this, run Ansible playbook, and you set up this. Okay, the things are done. Now you can go and just try to see if our etc hosts is proper on both the slaves. So I will go to see HDP S1, get on etc host file. Perfect. S2, get on etc host file. It is also perfect. Okay. So rest everything. Okay. We are not going to install MySQL separately. It would be the part of Hive installation. We will use the same. Okay, now that's done. Anything left? Nothing. So we have gone through the basic checks. We have gone through this configuration, correct? We created SSH passwordless. It is working fine. So this is the command that what it will do is basically there is a wget. So this wget is a Linux command, and if you give the overall URL address, and if there is a file, so this is the URL, and ambari.repo is the file that we are going to copy remotely directly to our that master machine. Okay, and then it is automatically getting copied into the ambari.repo in yums.repo.b. Okay, so I will just try to do that. Okay, so do go to cd/etc yum repos.d. So ambari repo has come over here, right? So if you open this ambari.repo, it is actually pointing to the public repo. So this is not our local repository, it is the remote repository of Hortonworks. Okay, so you just need to do sudo on this. Okay, so we just need to have this ambari.repo. Now you do just yum repo list just to refresh your repository. So your repo list is refreshed and you could find ambari 2.4.2 repo. Okay, so it is pointing to public/repo. So this is the website of Hortonworks where now all the RPMs will be picked from there and will be downloaded and getting installed. Okay, so this is the other way. No, so basically in production you are not going to use this. You still need to use your local HTTP repository. You need to build it. You need to have a complete package of HDP 2.5 or HDP 2.6 or any Cloudera version needs to be there on your local host, local repository, and all your nodes in your cluster needs to point to that local repository. Okay, website repository, basically web repository. But since why we are doing this, because again we cannot download 5 GB of those RPMs and put it in our local repository again, because the speed is so fast that we can still refer to remote repository and download everything from there. Just we did for Cloudera. So once do this, you can start sudo yum install ambari server. So it is going to pick from which repository? This one. These are the repositories. Say yes. So let it download. Okay, so everything's downloaded. It's now downloading PostgreSQL. Again, the PostgreSQL is going to be the database RDBMS for storing the metadata information of Ambari server. Okay, as we have seen that PostgreSQL is also like kind of the RDBMS used for Cloudera Manager. The Cloudera Manager also saves all its metadata information. So it creates few tables, and in that table basically it keeps all the metadata information about the cluster. Okay, you can have MySQL also in place of PostgreSQL, but then you need to either, once you start with PostgreSQL, you can migrate the data tables from PostgreSQL to MySQL. Okay, and that way you can just like you can have your own RDBMS can be used for either Ambari or Cloudera. So Cloudera Manager is done. Now we need to do sudo service Ambari server setup. So say Linux is set to permissive mode. Okay, one second. Basically before this, what we need to do is, we have not yet even set up the host name, right? So we need to do cd etc sysconfig network, and here we need to change the host name for each of these machines. Okay, so this is it there in this network? Sorry. This step might not be in the document, so let me put it. So after etc host, you can have set the host name to be host name with the domain name in etc sysconfig network file. The hostname for this would be HDP m2.cluster.com. So this is just for respective host names. Okay, so HTTP m2.cluster.htp-m2.cluster.com, and set it from the command line also, because we are not going to restart our systems. So I will say HDP. Did I put right? Yes, HTTP m2.cluster.com. HTTP m2.cluster.com. Verify it. We need to be sudo, sorry. Go to HDP S1 and do the same thing over there. See sysconfig network. HDP s1.cluster.com. Host name should be HDP s1.cluster.com. Sorry. Host name. Do similar for HDP s2. Any question? Eklavya. Anil, do you have any question?
No, nothing, Mama.
Okay, so be on mute. So, thanks. So SSH HDBS2. Go to vi/etc sysconfig network file. Change this to HDP s2.cluster.com. Save it. Sudo host name would be HTTP s2.cluster.com. Correct. Now run that command. Call sudo service ambari server setup. So yes, to continue, mode temporary disable, customize user account for Ambari server daemon, no. Go for JDK 1.7 to be installed with its encryption policy, cryptography policy. Okay, so the JDK 1.7 is downloaded. Say yes to no. So enter advanced database configuration. No, we are going to just use PostgreSQL with its default configuration. Say don't put any option there. Press enter. It is setting up PostgreSQL for Ambari. So it will create database. It will create tables inside it and then put all the metadata for Ambari. So our setup is done. We just now need to start the server. No errors were found, that's good. And ambari server is started now. Where we can listen it? On port 8080. So just say net state minus an LTP grep 8080. So this is the default port. You need to be root or sudo in front of it. And currently it is listening on port 8080. So we need to just ping the public IP address of it. This one. And put 8080 as a port. Sorry, 8080 is the port. Just like 7180 was the port of Cloudera Manager, 8080 is the port of Ambari. Again, it is all configurable. Whenever we say port, it is just a software construct, and if you really require different port mapping, port setting, port number, rules for your project, you can easily go and change in the configuration files. So this is the welcome page of Cloudera. Welcome page of Ambari. Do admin. Admin and admin is the user ID and password. Okay, so once you get this, you can go and click on launch install wizard. Okay, currently it is saying that there is no cluster register as of now. We can go on launch install wizard. You can provide the name of your clusters. I will say new cluster. Do next. You can just say default version of HDP 2.5. Currently we are going to use it, and we are going to point to the remote repository of Autonomous. So since we are using Red Hat 6, we will select this. Rest we can remove. So we just need to put Red Hat 6. It is pointing to the remote repository. Here it is saying use public repository. Else we could have our local repository if we would have set up it. We can select this one and point to our local repository, right? Everything is okay. Do next. Here we need to provide the host names, so you can just pick it up. HDP m2.cluster.com. Change this to S1. It should be S2. Add HDP m2cluster.com, HDP S1 S1, correct? Now we can put our private key. So private key can be brought from here. Go to SSH ULL, and this is our private key, right? So get on it and copy this key till here. Put it here. The user would be Iman10 because we had created passwordless SSH for Iman10, not for the root user, right? Just remind that. Register and confirm. Okay, now the guys got registered and we got success. So it is checking some potential problems. Okay, so we can see if Transparent his pages is the only problem, else everything is okay. So this is just a warning. It does not stop us to go ahead. Just close it and do next. Now here we can choose all the services at a time. Okay, so SmartSense Horton works quickly gather config. So SmartSense again we already got through, so these are all the basic Hadoop components like HDFS, Yarn, MapReduce, Stage, Hive, HBase, Pig, Scoop. Okay, let them go in single shot. What we are not going to install is SmartSense. SmartSense is, it requires some kind of license ID from Hortonworks, because what it does is Hortonworks SmartSense tool helps quickly gather configuration metrics, logs, and common HTTP services that also that it's to quickly troubleshoot support services. So basically, suppose if you are running a Hortonworks cluster and in production, and if you face any issue, you should have the SmartSense activated over there. So what will happen is basically whenever you create a support ticket to the Hortonworks, they will access this SmartSense and gather the quick information about your cluster and everything, because they might not know anything about your cluster. How did you set up? What are all the things running? What could be the problematic congestion or any other things that could be problematic for your cluster. So they cannot start from the scratch. So they keep that information available to them as and when they log into your cluster in order to get the troubleshooting done. Okay. Log erection and the service is technical preview, so we are not going to install it, and we are not going to install Spark 2 because they're all in technical preview. The rest everything is okay. What we can so one more thing. So basically when we install Hive, okay, it gives us the way of installing MySQL server automatically. Otherwise we may need to do it on our own, and then what we'll do is we'll start with the basic services. So I will go with HDFS, Yarn, and Zookeeper. Okay. I will go with this basic service, and then we will add Hive. When we add Hive, basically it will automatically install MySQL server and create, so it will actually properly set it up. Okay, and once that MySQL server RDBMS is ready, then we can install the rest of them. Okay, that would be the good one. So I will do next. Name node would be HDAM2, that is okay. Secondary would be gone to S1. Have timelines over S1. Resource manager on S1. Let it get to on M2. Have timeline server also on M2. History server, let it get to M2. Zookeeper server is going to be on everywhere, just to form a Zookeeper quorum. So let it go to M2. If we will set up the high availability later on, we can add them. So I'm just removing these two instances and keep them on. So this is how we need to be required. Okay, so Zookeeper will go through the basics and know everything about it. Currently we just need to see that how we can install the things. Go to next. On M2 we require data node everywhere, node manager everywhere, and client only on M2. It's through M2 only. So this would be treated as our edge node, though this is not the actual case in production. In production we need to have a separate edge node from the cluster. Though it is managed by Ambari only, we will have only clients in edge node, just like this part, not the rest of the services. So data node is on, node manager is everywhere. Do next. So customize is not required at all at this stage, because we do have ample of hardware resources available. What it says, maximum container size value is greater than 500. Maximum container size it would be 10 GB. So we can make it somewhat. So memory allocated for all yarn containers is to be 10 GB. So minimum container requirement is start, let's say, with 1 GB. So I will keep it on 1024, and it can go maximum to 2048, not more than 2 GB. Rest everything is okay. I will tell you more about why we have done this when we go through the yarn architecture. Okay. So the rest everything would be okay. Map memory 1024, reduce should be 1024, sort allocation, that is okay. App master should be not 1024. Next. Deploy. So things are getting installed. Okay, so you said that whatever memory like changes we had done, was it basically, yeah. So basically what happens is, whenever you start ambari server, when you start installing the things, it will grab the overall memory available, and depending on that, it automatically resizes some of the requirement, some of the memory requirement, right? So mostly what will happen is we will now go through the basics of MapReduce. Okay, so in MapReduce we do have tasks, map task and reduce task. Okay, so they will, and when we talk about those tasks, they are like individual JVMs. So we now know that in HDFS we do have multiple JVMs, like name node, secondary name node, data node. Okay, then job tracker, task tracker also there in the the for MapReduce. So each of these daemons, they are basically Java virtual machine, and when we set up the memory, so it is like the heap space or heap memory of those Java virtual machine. So I will let you know, I mean, it will be clear when we go through the complete basics of MapReduce, and what we will do is we will create one program, okay, fire that overall analytics on our cluster that we build, and try to see that where the logs can be seen, how many map tasks or how many reduce tasks get generated, what is the overall the logic behind how many tasks will be generated, and how each task will be executed. Okay, how can we see the logs, if anything is stuck, how we can troubleshoot everything. So we are just doing very basic thing, just first install the things. Okay, keep all the services, because unless we don't install our cluster first, okay, it is very difficult to go through the practical hands-on of those components, right? So first we will build our cluster, and then on each of the components we will start gathering all its basics, all its internal details, with all the hands-on on it. Okay, so
Okay.
for answering your question, why we changed it, yes, so basically 1 GB per task is enough. But yes, in the production, if you have really very large RAM, just like in our case it is 13 GB per node, right? So we have selected 13 GB, so total 39 GB of RAM we are having. In actual production you will have 300 GB, around 400 GB also RAM on per node. Okay, so, and for all the basic components of Hadoop, and since most of them are like all the Java virtual machines, we may give some let's say 10 to 20% of the total RAM available on your node will be gone to the components itself, like basic components that build your Hadoop. So those components run, they will require the RAM, right? So let's say 20% you have given them, 8 to 10% you need to keep it for your Linux operating system, and remaining 70%. So 60 to 65%, 5% again you just need to like kind of buffer, but 60 to 65%, that particular RAM you will allot to all the tasks that will do the analytics basically. So again, that would be either Spark or MapReduce mostly. Okay, so we will come to that point where you will definitely get the complete understanding of this.
No worries. Thank you.
Yeah, thanks. Okay, so the install started. Just do next, and we will see few services added to our cluster. Complete. You will see that these are the services gets added, right? So let's now add the complete remaining services.